Welcome. In this video I'm going to show you how you can obtain different types of means using R and my stikpetR library. I'm using Jupyter Lab, but all the R code should also work in, for example, RStudio. I'm having R version 4.3 and the only things that are at the moment installed are the basic packages that come with R. So a mean is actually a very generic term, and when people say mean, they usually refer to the arithmetic mean, which is also what they often refer to as average. Although there's also the harmonic and geometric mean, and those three together are sometimes known as the Pythagoras means because they have a geometry perspective that you can actually find them in. The arithmetic mean is somewhat of the balancing point of all the data. So it's the fulcrum, as it's called, and it's calculated by simply adding everything up and dividing it by the number of items, which also makes it like a social measure, as in it's what everybody would get if everybody would get the same amount. The harmonic mean is often dealing with ratios, where the geometric mean deals with compound interest. But there are more means. Because the mean is quickly influenced by extreme values, some came up with some ideas to counter that. So for example, a trimmed or truncated or Windsor mean simply removes some of the highest and lowest scores. A Winsorized mean doesn't remove them, but replaces them with the closest value that isn't removed or replaced. The Olympic mean I came across in one source, which was simply removing one maximum and one minimum and then calculate the arithmetic mean over the remaining scores. And the decile mean is actually the average of the 9 deciles, which are quantiles from 10% to 90%. I have a whole video on quantiles if you're interested in exactly what those are. There's also mid-range, which is the average of the maximum and the minimum. And similar, because that will be heavily influenced by extreme outliers or just outliers. The mid-quartile range does the same, but then with the first and the third quartile. I'll discuss the mid-quartile range in my quartile ranges video, so I won't be going into that one in this video. To show you how these means can be calculated using the stikpetR library, I first need some example data. For that I'll load the GSS General Social Survey from 2012, adjusted for some example purposes. I don't need all the data, I just need one numeric field, so I'm going to be using age. And that's what you can see over here. I'm removing the missing values. There was one who actually had an age, and there's an age category actually of 89 or older. I'm just going to replace those with the age of 89, and I make sure everything is numeric and store all of that as scale field. Now my library is available not on CRAN, so you first need to install DevTools if you haven't done so already, and then you can install it from my GitHub account. Once you've installed it once, you can always use then the importing just as any other library with library stikpetR. The function of interest is MA_mean, which is short for measurement and then mean, and takes as input, of course, the numeric data. If that's actually non-numeric, but you do have levels, then it can also work. If you don't have levels, you can just leave it empty. You can specify which mean to calculate. And for some of these, you will need a so-called trim proportion or a trim fraction. All right. And what to do actually if it's fractional, so linear or proportional or just round down. Now let's take it for a spin. So I'll simply type in the name of the function, feed it the data, and immediately it gives me the default, which is the arithmetic mean. Just to showcase all the other options, I loop here over all of them and show you the result and print it as well with all the different means. And that's how you can simply use my library to calculate some basic types of means. Hope this video was helpful and thank you for watching.